Welcome students for your third video for physics. Hope you all are keeping good. The last video we have studied about the types of motion and the examples related to it. Hope you have done your worksheets. Now today we'll be studying about speed. How do we define the speed of the body? The speed of the body is the distance traveled by the body in 1 second. The speed of the body is the ratio of distance and time. So it is mathematically expressed as distance by time. You can see it in the formula given here. The speed of the car over here is expressed by the distance covered by it in a given time. Here you can see how distance, speed and time are related. In the first case you will see the equation is for distance. So distance is the product of its speed and time. The second case is for time and it is the ratio of distance and speed. The third expression is for speed and speed is the ratio of distance and time. Speed is a physical quantity, so it will have a unit. Its SI unit is meter per second. Not only SI unit, but the speed has got a commonly used unit also, and that is kilometer per hour. The SI unit and the commonly used unit are related to each other. So this is how they are related. 1 meter per second is 3.6 kilometer per hour, or 18 kilometer per hour will be 5 meter per second. Motion possessed by any body have got two categories, uniform and non-uniform. So let's discuss the uniform motion in detail and see some examples. If a moving body travels equal distance in equal interval of time, this type of motion is said to be uniform. You can see a picture over here. It is of a car which are showing a motion. It has covered some particular distance in the given time interval. In the first 2 seconds, you can see it covers 4 meter. In the next 2 seconds, again it covers 4 meters. For the next 2 seconds, again it covers 4 meter. You can see it in the picture. So in this example, for different time intervals, the distance traveled by the car is given. You can see here in the table given. And talking about the time taken by the body, you can see that for every distance it has taken 2 seconds. We observe here that the body covers 4 meter in each 2 seconds. To simplify, 2 meter per second. So it is a uniform motion by the body. Next we will discuss non-uniform motion. So we will use some examples to understand this type of motion. So let's study the definition for this motion. If a moving body travels unequal distance in equal interval of time, such type of motion is said to be non-uniform motion. Given here is a picture of a car, you can see in the diagram. So it shows that in the first second it covers a distance of 4 meter, and in the next second it covers a distance of 6 meter. Next 2 seconds it covers a distance of 3 meter and 5 meter respectively. So in the given example, the distance covered by the car can be recorded as it is given in the table over here. From the picture we conclude that all these different distances which are covered by the car, that's all covered by the car in 1 second each. So we conclude that in the first second it covers 4 meter, next second it covers 6 meter, and then 3 meter and 5 meter in respectively each second. This picture shows the distance time graph for uniform and non-uniform motion. For uniform motion you can see a straight line but a curve for non-uniform motion. Now to differentiate the two types of motion, the car A showing uniform motion travels equal distance in equal intervals of time, whereas car B shows non-uniform motion with unequal distance covered in equal intervals of time. Given here are some other examples for uniform and non-uniform motion. To calculate the speed in non-uniform motions, we use average speed. It is the ratio of total distance traveled and total time taken. Given here is the mathematical expression for average speed. In the example of the car showing non-uniform motion, we have studied that it covers a total distance of 18 meter in the time 4 seconds. So by using the formula for average speed, it will be 18 meter by 4 seconds, that is 4.5 meter per second. So now the next topic to study is mass. How to define mass? It is the quantity of matter contained in a body. Mass of a body is the constant property of a body. Changing the position of the body won't affect the mass of the body. Take the mass of the body on Earth or on Moon, it is going to remain the same. So let's talk about the unit. Its SI unit is kilogram. It's got other smaller units also, like a gram represented by small g. The instrument we use to measure the mass of a body is beam balance. This picture is of a beam balance. Our next topic is weight. The weight of the body changes from place to place because it depends upon the force of attraction of Earth or any other heavenly body on the body, which differs from place to place. Example, weight of body on Moon is 1/6 of its weight on Earth. Because Moon's attraction for any body is 1/6 of Earth's attraction. To define the weight of the body, it is the force by which the Earth attracts the body. The SI unit of weight is on the name of the scientist Newton. It is represented by capital N. To measure the weight of the body, we use an instrument called spring balance. It has got a spring along with a scale on the sides. The picture is of a spring balance. You can see the spring in the center and a scale there. The other unit for weight is kilogram force. 1 kilogram force is equal to 10 Newton. Weight of the body is the product of mass and acceleration due to gravity. Study some differences between mass and weight. Mass is the content present in the body and weight is the force exerted by an object by gravity. Mass is constant whereas weight changes from place to place. For mass, we use beam balance and spring balance for weight. SI unit for mass is kilogram and for weight is Newton or kgf. Given here are some of the solved examples of numericals on speed and average speed. First example, the car travels with a constant speed of 20 meter per second. How much distance the car will travel in 8 seconds? Given here is a second example. It says the car travels 32 km during the first 2 hours. Then it travels 13 km in next hour. What is the average speed of the car? Thank you students. Please complete the worksheet attached.